Hello everyone, welcome back to the channel. So today's LeetCode question 3629, minimum jumps to reach end via prime teleportation. It is a medium level question and it has been asked in Uber. Okay, before going to the question, let's see the idea of calculating the factorization in minimal time. The normal approach of calculating factorization is just dividing a number till its square root, so the time complexity becomes order of square root of n. Okay, let's go through the concept of SPF, smallest prime factor. So what SPF represent is smallest prime factor that divides x. For example, for 2 it will be 2 only. For 6 it will be 2 because 2 is the first number that can divide 6. For 20 it will be 2. Similarly, if we see 9, the 3 is the first number that can divide 9. Then how we calculate all the factors of a number from the smallest prime factor array? It's very simple. Just divide the number with the smallest prime factor it has till you reach 1. So here you can see for 60 SPF was 2. So we divide by 2 and we get 30. So we get one factor, that is 2. SPF of 30 is 2. 30 by 2 15. 1 prime factor 2. SPF of 15 3. 15 by 3 5. 1 prime factor 3. Similarly the next will be 5. So 2 2 3 5 are the prime factors of 60. Okay, here I have written the code for calculating the SPF. So first we will take an array where all the elements will be 0 initially. Now we'll start our iteration from second element from 2. So whenever we see that SPF of I is 0 means a prime factor is encountered. So we'll just make the SPF of I with the index. So here you can see here 2. The SPF of 2 will be 2. And from now what we need to do from here, we need to check all the elements to the right which will have 2 as the SPF. So we will move in the length of 2. So 2 4 6. Now here why I am starting j equal to I into n. Suppose you are making a decision for 5. So 5 can jump from 5, 10, 15, 20, 25. This all guys can have 5 as their possible SPF, right? But if you see 10 will have 2, 15 will have SPF as 3, 22. The decision for the 25 will be the first guy which will have 5 as an SPF. So like the decision for like 5 is starting from 25 only. So here we can start from the square of that particular number. Okay, let's see how we can calculate all the factors from this SPF array. So the formula is very simple. For the number n, we will just divide it by SPF of n. We'll store this SPF of n and this will continue till n becomes 1. Consider here 15. The SPF of 15 is 3 and like we'll store 3 and 15 by 3 is 5. SPF of 5 is 5. 5 by 5 is 1 and we'll store 5. So factors for 15 are 3 and 5. I have written the code here. You can go through this. Okay, now we have the base for solving this problem. Let's go through the problem statement. So we have been given a nums array and what we have been told that we can jump from I to I plus 1 and from I to I minus 1, and one more jump is possible when the nums of I is a prime number. Then you can jump to any index where the nums of index means the value will be divisible by nums of I. So nums of I is a factor of nums of index. Here 2 can directly jump to 6 because 2 is a factor of 6. So the total jumps required here will be 2 only, from 1 to 2 and 2 to 6. So what we need to do is calculate the minimum jumps to reach the end. So the intuition is very simple. Whenever we see minimum jumps, shortest step, minimum operation or shortest path, think of graph plus BFS. Okay, consider this. We have been given an array, right? 1, 2, 3, 4 at the index 0, 1, 2, 3, right? And we have been told that from any index we can either jump to the forward index or from like to the one back, right? So it just represent a directed graph. So from this we can create a directed graph from like this 0 1 2 3, and we have one more like edge which comes from the prime factor node. So here 2 was able to directly jump to 6, right? So we can just add an edge here. So from 1 index we can directly jump to third index. Okay, now whenever we see graph questions, the directions are very important, right? we have been told that from any index we can either move to the forward index or we can move back one. So we have this information, but there is no information of the prime factors, no like connection, right? So what we can do is, see this, consider this 6. From the SPF method we have like discussed, we can calculate the factors of 6, which comes as 2 and 3. From this factors we can check what all like values are in our array. So we can see that 2 is present in our array. So this means that from 2 we can make an edge on 6. So from 2, which is at index 1, we can make an edge on 6, which is an index 3. So we'll need to store this information somewhere, right? So we'll just create a map where we'll just store the value, the factor value, and the index, like the here we'll not store the like value, we'll store the index where this value can make reach us. Okay, so for BFS directions, we have 3 directions: I plus 1, I plus 1, I minus 1, and map of like the third direction we will get from this map, where this will be the factor and this will be the indexes where this factor can take us. Okay, let's go through the pseudo code. So in the first step, what we'll need to do is calculate the SPF array for from the nums array. So we have discussed the code for this. In the second step, create the prime factors h. So we have the like first direction we have discussed I plus 1, second direction we have discussed I minus 1. For this is for the third direction. So how to calculate this, we have discussed this too. What we'll do, we'll just iterate to all the integers, calculate the unique factors for all. For 6 it will be 2 and 3. Then we'll check from this factors what all values are in the array, right? So here 2. At the end what we'll do, we'll just store this at somewhere. So we'll just make a map. So map of 2 will just add like the index of 6 to it. So 3 will be added. Here it will not be 6, it will be 3. Okay, so here we have taken the normal BFS setup, queue, added 0 to the queue, visited, make the 0 for visited as true. We have like created a variable for jump, initially 0. Now check this. I have taken an array 1, 2, 4, 2, 6. Whenever we are processing for 2, see where all we can go. I plus 1, I minus 1, and the prime factors array. So here you can see 2 is a factor for 1, 4, 2 and 6. So it can go to index 1, index 2, index 3, index 4, right? Now all this, after all the processing, a queue will be created which will have this 2 only, this 2 also, right? Now when the processing will be done for this 2, the second 2, what will happen is from here this index we can go to 2 like here and here. But this also allows us to like again go through all the prime factors location which we can reach. But if you see like this is just a repetition, like we have traveled this once, so no need to travel this again. So what we will do is we'll create a set of used prime numbers. Whenever there is a repetition of prime numbers, we'll just add to the set and will not process it again and again. Here's the basic BFS logic. So we will iterate till queue is empty. So take the current, check if the current is the last index. If it is the last, we'll just return the number of jumps till this. Then you visit the left and visit only when the visited array is false. Visit right when the array is false. And then for the prime numbers, check if the current number is a prime number and the use prime set which we discussed, it doesn't contains the prime number like this particular number. Iterate through all the like factors, iterate through all the values for which this guy is a factor and add those to the queue for the next traversal. Then make jump plus plus. So here for this array we'll first add 0 in the queue, then this will be removed. From 0 we can just go to 1, right? So we'll add the index 1, then processing for 1 will be done, this will be removed. From 1 we can either go back, but this is also already visited, or from 1 we can go to 4 or all the prime factors, like all the factors here. Okay, so from 2 this we added 4, the next index, and 6 will be added from the third direction we have discussed. So processing for 4 and 6 will be done, and we are here, look, we are also increasing the jumps for each iteration. So at the end the jumps will be returned. Okay, here's the time complexity and space complexity. I have written the complete code in the comment section. You can go through this. I'll request you guys to code this once. You will learn a lot. So that's it for this problem. If you are in the same journey of interview preparation, you want the content on LeetCode, LLD, HLD or GenAI, please follow along. The code will be given in the description. Thanks.